One collision in space could trigger thousands more, and if it starts, we may not be able to stop it. What happens if space becomes too dangerous to use? This is entry 006 of the Cosmic Ledger. This is the Cosmic Ledger. Right now, as you watch this, there are thousands of satellites orbiting Earth, keeping your world running. Your GPS telling you where to turn, your weather app knowing a storm is coming, the banking transaction you made this morning, the internet signal reaching your phone, all of it, every single piece of it, runs through space. You don't think about it, you don't have to. It just works. But there is a scenario, a real, scientifically documented scenario, where it stops working. Permanently. And the terrifying part isn't that it could happen. It's that it might already be starting. Here's the situation up there right now. There are approximately 27,000 pieces of tracked debris orbiting Earth. Defunct satellites, spent rocket stages, fragments from old collisions, shards of metal no bigger than a marble. And they are moving at roughly 17,000 miles per hour. At that speed, a piece of debris the size of a paint chip hits with the force of a hand grenade. A fragment the size of your fist can destroy a spacecraft entirely. We track the big pieces, we cannot track the small ones. And there are estimated to be over 100 million fragments too small to see, but large enough to be lethal. Every operational satellite up there is threading through that invisible minefield right now, every single day. In 1978, NASA scientist Donald Kessler published a paper that most people in the space industry quietly consider one of the most important and most disturbing documents ever written. His finding was simple. If the density of debris in low Earth orbit reaches a certain threshold, collisions won't just happen more often, they'll become self-sustaining. One collision creates a cloud of new fragments. Those fragments collide with other objects. Those collisions create more fragments and more, exponentially, unstoppably. This is Kessler Syndrome. And the math doesn't care how careful we are once it starts. It feeds itself. Think of it like this. Imagine a highway where a fender bender creates debris that causes 10 more accidents, each of which creates debris that causes 10 more. You can't clean it up fast enough because the crashes are happening faster than any crew could respond. Now imagine that highway is a shell around the entire planet, and there's no off-ramp. That's Kessler Syndrome. So what does the worst case actually look like? It doesn't happen overnight, but it compounds. First, low Earth orbit, where most satellites live, becomes increasingly hazardous. Operators start losing satellites to impacts. Insurance costs explode. New launches become a gamble. Then, GPS starts degrading. Not failing all at once, flickering. Unreliable. The kind of failure that cascades into shipping routes going dark. Financial systems misfiring. Emergency services losing coordination. Then, communication satellites begin going offline. Internet. Blackouts in regions that depend entirely on satellite connectivity. Billions of people. Then, and this is the part most people don't consider, we lose the ability to launch at all. Not because we lack rockets, because the debris shell is so thick that getting through it without catastrophic collision becomes near impossible. We would be grounded on our own planet, looking up at a cage we built ourselves, and here on the ground, we would still be dealing with the fallout because the infrastructure that runs modern civilization would be crippled. This isn't science fiction. This is the documented endpoint of a process that is already underway. So, can we fix it? The honest answer is maybe, but not easily, and not yet. Several approaches are being developed. Nets and harpoons, physically capturing debris and dragging it to burn up in the atmosphere. ESA's Clear Space One mission is testing this. It works in concept, but scaling it to millions of objects is a different problem entirely. Lasers, ground or space-based systems that nudge small debris into lower orbits where it eventually burns up. Promising. Still largely theoretical at scale. Robotic capture. Systems, autonomous spacecraft that dock with dead satellites and deorbit them. Japan's astroscale has made real progress here. But again, they're catching dozens of objects while thousands more are being added. And then there's policy, because the real problem isn't just the debris that's up there now, it's that we keep launching. SpaceX's Starlink alone has thousands of satellites in orbit and plans for tens of thousands more. Amazon, OneWeb, China's mega constellation programs, the sky is getting crowded fast. Without binding international agreements on debris mitigation, end-of-life deorbit requirements and launch limits, the engineering solutions are fighting an uphill battle. And getting countries and corporations to agree on space traffic management is, to put it diplomatically, a work in progress. Here's what I want you to take from this. We are extraordinarily good at solving problems once they become crises. But Kessler Syndrome doesn't give you a crisis moment. It gives you a slow accumulation, a threshold that once crossed tips into irreversibility before anyone sounds the alarm. We created this problem the same way we create most problems, not through malice, through growth, through success, through assuming the sky was infinite. It isn't. And unlike pollution in a river or smog in a city, you cannot clean up low Earth orbit with political will and a generation of effort once the cascade begins. The physics won't wait for the paperwork. If we lose access to space, we don't just lose exploration, we lose the systems we depend on every day. The timing of your food's delivery, the forecast that warned your city about a hurricane, the transaction that paid your rent. All of it, threaded through satellites that exist in a shell we are slowly filling with wreckage. And the moment that cascade starts in earnest, we may not be able to reverse it. This has been entry 06 of the Cosmic Ledger. The ledger stays open.